Hello and welcome to the second video on base 5 numbers. So to emphasize the counting in fives a little bit better, we are going to do base 5 arithmetic, meaning we're staying in base 5 and we're going to add and subtract some numbers. And that really emphasizes that if you can do this, then you really understand the counting concept in fives. So let's have our little exercise here, exercise 7.4. Perform the following arithmetic calculation within the base 5 number system. So first I have to remember, maybe let's backtrack a little bit. First, let's remember our way of adding in our number system that we grew up with. If I, for example, have 217 plus 529, how did we do that? Well, the first thing we learned was right to left. We're going to go this way. When we said 7 plus 9 is 16, keep the 6, carry the 1, and then count in the tens column. Because 16 is 10 plus 6, or one group of 10 plus 6. So 1 goes over to the tens column. 1 plus 1 plus 2 is 4, nothing's carried over, and 2 plus 5 is 7, and we're done. We're going to do the same thing, but we're going to remember to count in fives. So the first one here, A, is going to be, well, I'm going to use the same method. So this emphasizes the basic method for adding right to left. It's the same method, but we're going to count in fives to really emphasize and focus on what the method is doing. So the first thing I did was line everything up correctly. So we're going to do the same. So we have 2, 4, 1, 0, base 5, and I give myself enough space to line everything up. 2, 4, 3, 0, base 5, then my line, and I'm ready to start. Right to left, the method does not change. 0 plus 0, 0. I am making a base 5 number. That subscript has to be everywhere. Even though it looks like a little scribble, I have to write it everywhere. 1 plus 3 is 4, and I'm allowed to write the digit 4. It's only when I fill up my 5 grouping. Then move on to the next column. 4 plus 4. 4 plus 4 is 8. I can't write an 8 there. Oh, no. No. There is no 8 in the base 5 system. The only digits are 0, 1, 2, 3, and 4. As soon as I have an 8, do it on the side here. As soon as I have an 8, it's one group of 5 plus 3. So the 3 stays, and I make a group of 5 carried over there. Then I have 1 plus 2 plus 2. That's 5. I can't write a 5. 5 is one group of 5 plus 0. So the 0 stays, the 1 carries over, but there's nothing else there. So 1. So 1, 0, 3, 4, 0. That might have felt a little uncomfortable for you, but with repetition, it will get better. Let's see the next one. And remember, you can always pause if you want to see this further and look at it and stare at it. You can do so, just pause the video. Next is 110, base 5, plus a 4-digit number, 4, 2, 3, 4, base 5. Now we have to get used to not writing any decimal numbers and doing this in our head. You stay in the base 5 number. Let's try it. 0 plus 4, 4. Easy. 1 plus 3, 4. I didn't fill my group of 5. 1 plus 2, 3. And 4. Oh, so easy. There's nothing to carry over. Very little to do. Hopefully the next one will be a little more interesting. It's the carrying over. Let's see the next one. 1, 4, 2, 3, base 5. 1, 0, 0, 4, base 5. All right, right to left, the method does not change. 3 plus 4 is 7. I can't write a 7. 7 is 1 group of 5 plus 2. 1 group of 5 carries over, 2 are left. Next column, 1 plus 2, 3. 4 plus 0, 4. 1 plus 1, 2. Remember that we're counting in fives. That is the key here. Alright, let me make a new page. And we can go to some subtraction. Counting in fives. So that when you go back and look at your decimal system, you'll look at it much more objectively and be more aware that we're counting in tens. So the only way to really be aware of that is to change the group size that you're counting in, like a 5. And really look at what the method is, how the method works. Let's see. Subtraction. 3, 2, 0, 1, base 5, minus 2, 2, 0, 4, base 5. Now I'm just going to make a new page here for a second so that we can remember how did we learn subtraction, the subtraction method, growing up in school. How did we learn it? I say the method's not going to change. So let's remember subtraction in decimal. Sorry, that N is horrible. I can't live with that N. I tried to fix it, didn't work. Subtraction. And we grew up with the decimal numbers, but we get so used to it, we stop thinking what this method actually does. So let's pick something here. Let's pick 271 minus 28. What did you do? We said, well, it's right to left. 1, take away 8. It can't be done. There's not enough. I have only one thing, so I take away 8. So you borrow from the 7. The 7 becomes a 6. Now what we unfortunately do in school is we put a little 1 there, read it as 11, and then do the subtraction. That's not really what we should be doing. When you you split the 7 into 6 plus 1. This 1 that comes over now becomes 10. And with the existing one there becomes 11. 11 minus 8, 3. That 1 isn't there anymore. It now becomes a 10. Because I borrowed it from the tens column. 6 minus 2 is 4, and I can move on. So let's keep that in mind when we do this. So now, 1, okay, this is a difficult first example, wow. I think I'm going to put a pin in this one. We're going to come back to that one. It's still there, don't worry. But I'm just going to do B first. Right now, I think maybe B first. Yeah. Ooh, B stuff too. I'm looking for the easiest one. Okay, no, I'm back to A. Oh no, what am I doing? Don't worry about what I'm doing. I know what I'm doing. Maybe you can handle it. Let's handle it. Let's do it. We can do it. I have confidence in you. Okay. I thought I could make an easier one. I thought for the moment B would be simpler, but not really. We can do it. Subtraction is going to be a little tough, but let's focus and go slowly. So, I say 1 minus 4. One's not big enough. So I have to borrow. But, there's nothing to borrow. What do? I have to borrow from here. So this guy now splits into a 1 and another 1. 1 plus 1 is 2. This one is going to be carrying over to a lower column and split into, I'm going to make 5 little rocks here. Because I'm not allowed to write a 5. There is no 5 symbol in the base 5 number. When I take 1 and I split it open, it's like a little baggie. It's like a little baggie. It was 1 bag here, but now I open it up and out pops 5 little things. That bag isn't there anymore. Only the 5 little things are there. Now I have 5 things here that I can borrow from, because my ultimate goal here is still to have enough to subtract 4 from in the ones column. I can then take one of those, which really is its own little baggie, that I split open and make 5. Isn't this fun? How many things do I have here? Well, in our language, we can say 6. We just can't write 6. There is no 6 symbol. But we can say 6. 6 take away 4, 2. How many do I have left here? I only have 4 left. 4 take away 0, 4. How many do I have left here? Only this one guy. But I'm trying to take away 2. That's not going to work. So I need to borrow 2 left. Take one of these baggies, split them open, and 5 pop out. So how many do I have now? 6. Take away 2 is 4. 2 take away 2 is nothing. Let's just pause there, because that might not feel super comfortable. But remember, a first example isn't always going to be the best. But in time, it's going to get better. Let us try this next one now, which I thought was better, but I don't know if it actually is. I'll look silly if it actually is, but, we just take them as they come and borrow as we need to borrow. Whatever. All right. 0 minus 4. Nope. Did I write a 5 there at the bottom? Yes, I did. Okay. 0 minus 4 is not going to fly. I have to borrow. Then there's nothing left, but I split open my baggie, and out pops 5 little singles. Now I have enough to take away, and I have 1 left. But moving on to the second column, I need to take away 1, but there's nothing. So I need to borrow this one. This one baggie splits open and becomes 5 little singles relative to that column. Take away 1 of them, I have 4 left. Now, moving on to the next column, I want to take away 4. There's nothing there. So I have to borrow 1 there, leaving me 2, and that splits open to 5. Take away 4 is 1. 2 minus 1, 1 as well. So the borrowing is really emphasized when I'm counting in something other than 10, because I'm not conditioned. I'm not used to counting in 5. So that forces me to really think about what this method is doing, which is a good thing. Let's see, there's one more. C. 3, 0, 4, 0. Minus 2, 3, 3, 3. Let's see. Whoops, that was not a horizontal line at all. That wasn't a horizontal either. Maybe I should use my line tool. Stop thinking I can draw straight lines. 0 minus 3. Nope. Not gonna happen. Borrow. Split open into 5 because I'm counting in groups of 5. Now I have 5. I can say 5, I just can't write 5. Because there is no 5 symbol in this number system. 5 minus 3, 2. 3 minus 3, okay, I can do that. 0. And now the next column, 0 minus 3, oh, it's not enough. Borrow 1, leaving 2, and that 1 splits open when I move down to another column. 5 minus 3 is 2, 2 minus 2 is nothing. So with repetition, it's going to get better. You just have to give it time. Give it time. The last one we're going to do is good old multiplication. We can't leave it out. It wants to play with addition and subtraction. Can't leave it out. But in my experience, I feel it's a little easier actually than subtraction. So let's see. No, the first one. 3, 0, 4, 1, which is the base 5 number, times 2. Now let's just remember how we learned multiplication in the beginning. Because you might be tempted to say, let's say here, decimal multiplication. You might be tempted to say, if I have like, 235 times, 3, to say 3 times 5 is 15, 3 times 3 is 9, plus 1 is 10, 3 times 2 is 6, plus 1 is 7, and I'm done. But that is hiding a lot of detail that I now want to see in order to keep track of these 5 groups. So instead, I'm going to do the detailed version, which is 3 times 5 is 15. Then when I'm multiplying this 3 with this one, my answer is going to start over here, which means I'm padding with a 0 to keep everything in line. 3 times 3 is 9. Now my answer is going to start over here. So I'm padding with 2 zeros. 3 times 2 is 6. Now I'm doing the addition, which is 5. 1 plus 9, 10. So 0 left over, 1 group of 10, 7. This is going to be much better when I'm out of my comfort zone with these more difficult groups of 5. So that's what I recommend. 2 times 1 is 2. So now I'm going to multiply the 2 with the 4, so my answer is going to start there. So I'm going to pad it with a 0. Now I'm going to do 2 times 4. 2 times 4 is 8. I can't write an 8. This is a base 5 system. There's no symbol for 8. 8 is 1 group of 5, 3 left over. Now I'm going to multiply with 2 with this number, so that means I need to pad with 2 zeros. 2 times 0, however, is 0. Then I'm going to pad with another 0 to keep everything in line. 2 times 3 is 6. There's no 6. 6 does not have a symbol. It's 1 group of 5 and 1 left over. Add those up, I get 2 backwards, 3, 1, 1, 1. And there's my answer. The method does not change. My awareness of that method, however, does whenever I'm out of my comfort zone. Let's try 4, 2, 0, base 5, times 3. 3. Alright, 3 times 0, 0. You can write the 5 there always if you want to, because that is the number system we're working in. 3 times 2, well, I have to pad it with a 0 so that I'm lining it up here in line with the 2. 3 times 2 is 6. 6 does not have a digit in base 5. It's 1 group of 5 and 1 left over. Pad it with 2 zeros. 3 times 4. I have, in my language, I say 12, but I can't write 12. 12 is 2 groups of 5, 2 left over. Now I'm adding 0, 1, 3, 2. Very rarely is there carryover issues with this addition at the end of the multiplication. It's the counting in groups. You cannot write any digit other than 0, 1, 2, 3, and 4. Anything else needs to be split up into groups of 5. The last one, or is there 4? No, there's only 3. Last one, 1, 4, 0, 1, base 5, times 4. Alright, let's do it. 4 times 1, 4. Pad it. My 5s are becoming very messy. It's okay, as long as something's there. 4 times 0 is 0, however. Pad it. I know I didn't perhaps need to do that because of the 0, but I'm always doing the same method. Doesn't matter what the digits are. 4 times 4 is, 16. I don't have a digit for 16, but I'm counting in 5s. I close my eyes. 16 is 3 groups of 5 and 1 left over. 3 groups of 5, 1 left over. Add with more zeros. 4 times 1 is 4. Nice. Adding 4, 0, 1, 7. No 7. Close my eyes. 7 is 1 group of 5 plus 2 singles. And that is base 5. And there is multiplication done. I won't torture you with division because the method isn't quite the same as these ones, and using a different number base doesn't really add that much to my understanding of division, so I leave it. It's just messy and a little unnecessary. Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Also, please visit me on my Patreon page if you want to support me in making further content. Thank you.